In 2006, Pluto's reclassification became a major turning point in modern science, redefining what it means to be a planet and reshaping humanity's understanding of the solar system. It was more than a technical adjustment. It carried emotional weight, as something familiar and long accepted was suddenly reinterpreted. For decades, Pluto had been taught as the ninth planet, small, icy, and distant, orbiting beyond Neptune in the cold outer regions of space. It held a symbolic place in textbooks and imagination, representing the far edge of our known planetary system. Then, without any physical change in space itself, Pluto was redefined by scientific consensus. It was reclassified as a dwarf planet and placed within the Kuiper Belt, a region of icy bodies beyond Neptune. This decision changed a long-standing definition that had remained stable for generations. While Pluto's physical orbit remained unchanged, its identity and human understanding shifted dramatically. In education and popular culture, it gradually lost its status as a major planet, becoming a minor reference in astronomy discussions. Yet in reality, Pluto continued its distant journey around the Sun, unaffected by human classification. For a long time, scientists believed Pluto was a cold, inactive, and geologically dead world, an ancient frozen remnant of the early solar system. This view changed completely with NASA's New Horizons mission, launched to explore Pluto up close after nearly a decade of travel across billions of kilometers. When New Horizons finally reached Pluto in 2015, it revealed a world far more complex than expected. Instead of a static icy body, Pluto showed frozen plains, towering water ice mountains, deep valleys, and signs of geological activity. The surface was dynamic, not dead. One of the most striking features is Sputnik Planitia, a vast nitrogen ice basin shaped like a bright heart. Despite its calm appearance, it plays a role in Pluto's orientation and long-term surface behavior, hinting at subtle internal dynamics. These discoveries raised new questions about Pluto's interior. Scientists now consider the possibility of a hidden subsurface ocean beneath its icy crust. Although Pluto is extremely cold and far from the Sun, heat from radioactive decay inside its rocky core may still be present. Over billions of years, this could be enough to maintain pockets of liquid water underground. If true, Pluto would not be a frozen, inactive object, but a layered and evolving world with ongoing internal processes. Where liquid water exists, chemistry becomes more complex, opening possibilities for prebiotic conditions even in extreme environments. Pluto's thin atmosphere, made mainly of nitrogen with traces of methane and carbon monoxide, also contributes to slow chemical reactions. Sunlight triggers the formation of tholins, organic compounds that gradually coat the surface in reddish tones. These materials are linked to early chemical processes that may resemble the beginnings of life on Earth. Pluto's system is further complicated by its large moon, Charon, with which it forms a binary system around a shared center of mass. This unique relationship creates tidal interactions that may contribute to internal heating and long-term geological changes. Together, these findings suggest Pluto is not a static relic but a slowly evolving world with hidden activity beneath its frozen surface. Even if no life exists there, it challenges the idea that distant objects in the solar system are inactive or lifeless. Pluto is no longer just a lost planet. It is a complex and evolving world that continues to reshape our understanding of planetary science and the hidden potential of the outer solar system.